Hello everyone, and welcome to our SFC Energy hosted presentation by Schneider Electric on wireless information network solutions offering. With us today we have Quinton Williams from Schneider. Quinton, if you could advance the slide to the next slide, representing Schneider's Foxborough offerings, instrumentation, as well as the remote operations products such as DataPack, Trio data radios, and other types of products which are operating in the wired and wireless space. But in addition to that, we have a long history of working in the off-grid green energy market with our EFOY fuel cell, hybrid solar fuel cell systems, and we have many partners across the world representing those products as well. So we've been in operation for many years, and we've reached some very high sales volumes representing Schneider's products as well as the EFOY systems across the world. So we're very glad to be able to present today Quinton Williams from Schneider. Before perhaps we get going, I should point out that on the bottom of the screen there is a Q&A button. If you're looking to post a question, please use the Q&A button, press that, and type in a question. We'll be taking questions at the end of the session from some initial questions that we thought of, as well as questions entered in the question and answer section at the bottom of the screen there. So see if you can find that.
Thank you, Paul. I appreciate this opportunity. As you can see from my picture, that I'm aged 21 years working with Paul, and I think has done it to me. It's either that or my children, but for 21 years I've been with, it's actually 23 years now, with Schneider Electric. I started out with Foxborough and Vince's, and then with acquisition, I moved into many different roles within this company. So the last role I had, I managed North America, and now in this global role of presenting and supporting the wireless information network solutions. So I'm really excited about this. It was an excited part in my career to look at this and stand up a brand new product. As you can see, that it's right along my educational background. I earned a degree in the Bachelor's of Science Mechanical Engineering, so you know that dealing with electronics and wireless is right up that degree. That's a little pun there. I am a mechanical engineer, haven't done that in years. That was my degree and had fun doing it. So that's a little bit about me. Now let's get into the exciting part that I'm really excited to be here and talk about, and that is our wireless information network solutions. And if we look at wired devices and what they do, they truly, and I always say this is oxymoronic, wireless solution reduces wire cost. We know that. But there's a lot more to that than just the wires itself. It reduces engineering costs by how it's implemented. It really does. It takes the efficiencies. When you need measurements and you need them back quickly, you can do this with wirelessly, and it's very simple. Not a lot of planning, but just get it into the network and you're done. The other things that it really drives is digital information, and I want you to think about that all the way through this whole presentation. As we go fast forward, I think in the last 2 years, our lives have all been changed. I know mine has, and how we live in these little boxes on the Zoom calls, Teams calls, whatever else they may be called, webinars. But that's where we've lived for most of the last 2 years. Now that we're opened up, I'm out traveling, so I give you this opportunity. I'd love to be out and meet with you. I believe we're allowed to cross border excursions. So I do live in the United States in St. Louis, Missouri, which is pretty central for travel. I will be out here. But as I was going to digitization of information, it's out there. We see it fast forwarding into life. We see it in our own homes through Nest and other communication paths. It is happening, and that same thing is going into the wireless or the industrial world. What we used to call as process automation is now known as OT, or operation technology, differing from IT. But there's emergence between OT and IT causing the IIoT, which is Industrial Internet of Things. Now that is a little different than what you look at your Nest, the other devices in your home, which is the Internet of Things, empowering those devices. But this digital information trend is moving into the industrial world or the OT world. And you're seeing things with improved efficiencies in your operations, improved information flow that helps you do a better job of analyzing your assets and managing those assets. And when I say assets, I don't mean just device level asset. I truly mean your asset, your rotating equipment, your processes, and the rest of the things that are needed. It also enables you to have a better handle on your safety and on your compliance. So those are the things that digitized information is allowing us to do in the next generation world. And if you look at the WINS portfolio, what we offer at Schneider Electric, it's not just one single product. It's a broad spectrum of products. If you notice on the left-hand side of your screen, there is some, it's economical. These are the things that we believe have to exist in all products that we bring to market, or it's not practical. So it has to be economical. And I'm not saying necessarily in every single time is it the lowest cost, but and for this instance, it is. Instance to install, but it's not just the initial capital cost, it's installation cost and operational cost over the life of the device. So that whole life cycle has to be economical. And when you install it, it has to be reliable. So it has to last a long time without any worry about what you're going to do to this device. How much maintenance is required? What are you touching this device? So it has to be reliable. And ease of use. I mean, any more that you see devices, whether it's setting your phone up, whatever that is, it has to be simple to use. And we meet these criteria. And then safe, secure, and sustainable. Everywhere in the world that we have to have the sustainability. And I will talk about our product, Ian, for specific here and how it is sustainable. It truly meets the world of sustainability. And when I talk about sustainability, I mean the device and how it was designed and engineered will last the usable life of that device without touching it, without maintenance in it. So that is truly sustainable. If you look from left to right across the mid here, we'll talk about our bottom is short, mid, and long range and communication, the rangeability of the device. And what we mean that is how far and how many kilometers or meters that will. So on the left-hand side, you see short range is instrument area network, which we'll talk about today. Mid-range is what we call Accutech, 900 megahertz, a proprietary protocol, and it's under a kilometer. And short range, what we call under 200 meters. And if you look at the long range, that's a remote monitoring, which is center on product line, and our data logger. Those are both LTE or LTE devices, which have long range. And there is really nothing that's stopping the rangeability of those devices. So within the Schneider portfolio, we have all breadths of the product line that last. If you look at what the world will look like in this new digitized information world that we see, you'll notice there'll still be wired devices down here that are connected to your control device, whether it's a PLC, a DCS, or an RTU, it'll still be connected. And if you look at the standards that I did not include it in this presentation, but it's available out there if you Google it and look up ISA standard on control and safety and where they recommend wireless versus wired devices. So safety will always be a wired device. It hasn't been until recently that they allowed smart devices. They were always analog, and that was always for that safety instrumented system, or SIS. The next layer is what we call critical control, and that layer will always be wired, at least it is today. Now, I say that today, and things change, because if you've looked and opened the hood of your car, most new cars, there is no steering shaft left. There is wires that go down to a rack and pinion box into your steering wheel that's connected via transducer that turns in a potentiometer that gives it position input. So things can change, so I never say never. But this is as it looks today. So you'll have devices that we have out here on our Accutech or long range devices that are, the density is what we would call the measurement, a few measurements that you're trying to bring in from long distance away, kilometer or less. You might use an Accutech or a 900 megahertz device to bring those into your control system. And again, back into a central control through a base radio or what we call a gateway. Then you have long-term assets. Maybe that's a pond or remote pump setting out there that you need to bring in, and that's several kilometers away or even further, that you would bring up through a data logger accessing LTE, 4G, 5G into a cloud-based solution and down into your own customer application and into your server. And then what we'll talk about today is instrument area network, or IN is what we call that, which is a wireless Hart network that uses that as technology to do a mesh network into your control system, where a heavy density of measurements are around, and it's more practical to use that such a device or that kind of control system or a wireless network. So there is not one single thing that fits every application. So just remember that. If you have questions at the end of this, please remember that there is not one measurement type that is in one. There's places for wired, there's places for 900 megahertz, which is moderate in length and with density of less than hundreds of devices, a few devices. And then there's LTE that's available in our data logger to bring stuff in. So let's think about that all the way through. So why Schneider? Why would you want to look at Schneider for your wireless solutions? Well, we're just not one. We're not just still devices. We're multiple that. We don't just provide flow and pressure and temperature. We can, but we provide information that can help you run your business and run your plant better. We're not just one technology. I just talked about that. We're Bluetooth low energy, wireless Hart for short range. We're 900 megahertz for long range, and 4 and 5G for ultra long range. So we have all aspects of that covered. We're just not one technology. And again, we don't just try to shoehorn you into one technology, what fits best in your application. And it's finally at the end, we are a process automation provider, or OT, but we really want to be your partner in the IoT as we transition from what was process automation into this new digitized world of IoT. So that's why Schneider, and hopefully in the next few minutes, I can explain that to you, and I'll give you about 20 to 30 minutes, and then some Q&A after that. If you have questions, please just put your hand up and we'll address those at the end of this presentation. But here we go. The instrument area network. You'll hear me use the words from now on, IN. So it is IAN, instrument area network. And why we named it that was there would be an area, just like a process control, a little area of instruments that we'd pull together into a single device and then put that into a mesh network. So if we look at the basics of what makes up the IN device, as you can see on your left-hand side, there's a central concentrator. Within that central concentrator, it has 3 radios or 3 radio types. I talk to different people and they'll say, well, do you have a radio? And I said, yeah, actually, we have more than one. We use wireless Hart, which is the top radio. We use Bluetooth LE, which is low energy, to communicate with our end nodes. And we also have a Wi-Fi. Now, this Wi-Fi network is not the network we're communicating today. It is its own little network. If you've ever seen a football game and seen the coaches on the sideline with the iPads or whatever type of tablet, they're communicating with their own Wi-Fi bridge that shares and floods information, streaming information from the press box. Well, the same type of thing. It's not streaming, but what we have is set up our own individual network that we use for configuration. So there is 3 radios within the central concentrator. Why do we call it a central concentrator? It does that simple purpose. It is a concentrator of measurements, hence the term instrument network. It takes up to 8 devices and concentrate them into one device and then sends out a signal. So our end nodes communicate Bluetooth low energy, or BLE. I'll use that from now on as an acronym. It means what it is it's the new technology of Bluetooth. It will be the standard throughout the industry now. Everybody is switching to this, and it's actually Bluetooth 5.0 and beyond. But that gives us the ability to have a radio frequency that is very available. It's low energy consumption. And one of the things with wireless networks is they're autonomous devices that have battery operated, and battery consumption is one of the largest reasons why. If you'll notice that we have a little different in our look, I argue that it is what would have been. It used to, years ago, you would have looked at a Rivian truck and said, that's not a truck, but that is the world we're going to. Things are changing. Where Tesla cars were not what cars looked like, they are today. So I would argue that the devices that we have here in front of you, Ian, does not look like your traditional OT or heavy industrial process automation device, but it is. The reason it was designed this way is for practicality, to make sure that we have a device that lasts as long as it's supposed to, and also optimize radio frequency. So that's the basis for the Ian device. And let me dig in a little bit further and give you some more information. And the first is, why BLE? Why did we choose BLE? We like to say that it's a lot of power in a little footprint. And there's 2 reasons for that, or multiple reasons, but the first 2 is this. The chipset is very small. It's actually a real small chipset, gives us the ability for lower cost, to lower the cost, and also, as far as I said, is energy consumption. And why is it big? Well, there were 6 billion devices shipped in 2020, and that is growing into 2021. Have not got the report yet of what was shipped in 2021, but that is growing. Now, most of those are not into our segment. Those are used throughout the home industry. You see in your cell phone, in the cars, and everywhere else. but over 300 million were shipped in the industrial marketplace into our world, our OT world. Now, those were not used to do it as we are doing it today. They were usually for configuration. There's other manufacturers that are using it to pull information to send it into a cloud service that they have available. But we are the first to use it as a primary variable. But why is that? The reason goes back to those first two reasons. It's a little chipset. It sits in there. It's easy to remote. It also gives us the power without sucking our energy out of our battery, because the autonomous device is what it is. If you look at our device, and you'll see there is no way to change the battery. And I know some of you are thinking, well, good is that to me? I will show you, because of the way we use Bluetooth and the way we use this technology, that we do not need to replace the battery, that this device is completely sustainable, that it was designed to last the usable life of the device. And I want you to think about that as I move through this. How long do you expect the device to last in the field? So think about that and get some number in your head. And as we move forward, we'll talk about that. So back to Bluetooth. So it's available. There's lots of chipsets out there. The technology is cutting edge and growing. And talk about radio frequency. I believe that this will be one of the three that last into the future. I believe that Bluetooth, Wi-Fi, and LTE we'll see in 5 to 10 years from now. Some of the other technologies we won't. So that was the reasons we built this on. It also gives us the ability to stream lots and lots of data in a very short time without using a lot of energy. For example, a Bluetooth, you can move 800 packets of information a second. And the reason I say packets, that's what we're sending. The information is digitized, again, back to that digital transformation, and then send a packet of information. Within that could be multiple variables, your primary and secondary and tertiary variables. So if we compare that to wireless Hart only gives us the ability to send 40 packets a second. So as you can imagine, 800 packets is 20 times the amount of information that can flow. Now, what is in those information packets? So as I said, there is the primary variable, the temperature, pressure, what you're measuring or flow, but there's also other measurements that we put on board this device. And that is an accelerometer, an impact, acoustic, ambient temperatures and pressures. They're all sitting there and they're being streamed so we can get that information. So that's why we say Bluetooth, and this is why we used it. A lot of power in a little footprint. So if we look at safety, that's another important aspect of wireless or anything, but especially wireless devices. How do I know this can't get hacked into? So this is not your standard Bluetooth. Even though now if I send it out and I push the button on my device and it sends out a signal, you would not see that on your iPhone. It would not be able to pick up and move. That is called GATT. There is a lot of reasons we don't use GATT today, which we might in the future. But anything we do for advancements is software selectable and upgradable. So it makes it a life of device, again, sustainable for the future as we move. So let's look at security. There's 4 things of security that we look at, and that's authenticity. If you've ever hooked your phone to earbuds or to a car, you know, there's this change of a key and password code. That's what that's called pairing. We do bonding. What happens is the concentrator and the end node exchange a number. They talk to each other and say, as they're communicating, yes, that's the number. We agree. Now we're bonded. We're hooked together. I like to say they're married. They're hooked into this device, so they're hooked for good. So that's called bonding. So now you have that device bonded. No one else can break into that network or that device without having that shared code. The next is integrity. So that is the integrity of the information that's sent, those packets of information. We'll talk a little bit about that in the next slide of how this information flows. But as those packets are being transmitted, there's a digital signature that's attached. If they do not read that digital signature or it does not agree with what we have, it will not accept that information. So there, you cannot get a virus through. And then confidentiality. How do we know this is what it is? Well, it's an encrypted data it's truly encrypted. It's 128 AES that meets the encryption codes to today. And the result of a private address. Each end node has its own address that is only known to the concentrator. So between that little network, they are secure, and that is the secure information. So what we say is safety first. If you look how Bluetooth works, frequency hopping is what it's called. And the way that works, a lot of things are out on the market at 2.4 gigahertz, and that's what Bluetooth is. Wi-Fi is 2.4 gigahertz. Wireless Hart is 2.4, so is ISA 100, but there's lots and lots of others out there at that frequency range. So the reason that we have frequency hopping is to make sure that it covers up if there's any noise that happens within those frequency range. So if you look at wireless Hart, there's 16 channels that it can hop to. If we look at Wi-Fi, there's 3. What within BLE, there's 40 different channels. Now it starts on 3 primary channels, and as you can see, that 37, 38, and 39, that what we call is the primary advertising channels. So when you first start that communication path, that's the ones they start on. But if there happens to be noise because of all that other 2.4 gigahertz signals in your plant, in your environment, they will say to a predetermined hop, let's hop to the next segment, whatever that may be, 3 or 4 channels down the line, and that's where you communicate for the secondary advertising signals. So now you've made the agreement, you know that this is the device I'm talking to. So now when these secondary advertisings, as they call it, come down the line, that's where it's going to do and hop to. So this gives you the ability to hop up to 40 times, and it'll continue to hop to a predetermined agreement to make sure there is no noise within the cycle of where you're at. So let's dig in a little bit deeper. That's how Bluetooth is. That's why we've used Bluetooth. That's why we've based all of our technology on Bluetooth. We believe it's the wave of the future. The amount of devices out there today are too many to support if you go anywhere. I think there's over 13 billion devices that are in the IoT world now within Bluetooth. It's growing past that, but that was the last data that I had. And again, I said 300 million devices within the industrial world. It's here to stay. It's here to last. I can't guarantee what will be and 20 years out, but I can say that in 5 to 10 years that Bluetooth low energy will be one of the radio frequencies that lasts. So back again, let's look at the end device and how it's made. So our end nodes communicate Bluetooth. We talked about that. We talked about the advantages to that fast communication speed. There's something else that it does. We used a different kind. If you look at it, it's hard to see on this picture here, but underneath the top, there is a ceramic antenna. And that ceramic antenna basically causes the radio frequency waves to scatter. And doing so, it gives you the ability, what we like to say, see around the corner. Radio waves can't, but the scattering of those gives us the ability to have solid communication from the end node to the concentrator. And why I say solid, because it's an infallible distance. You must have your battery, you must have your device connected to communicate. And if you stretch that too far, then your communication is not valid. So it's not infallible anymore. The other thing about that design is that we want to make sure that connection is always there. What happens, and I'll be rhetorical here, if you have a cell phone, you're out of cell phone range, or you have your Wi-Fi turned on and you're hooked into a network and it keeps on trying to reconnect, it drains your battery. We know that Apple specifically will tell you if you have a low battery and you have a low battery case, you turn off your Wi-Fi, you turn off your Bluetooth, and it helps improve your battery life. Well, the same thing goes if you have a solid connection on your device, you will not lose your battery. So think about that. That's one of the reasons we did. So again, the end node communicates Bluetooth to the concentrator. Now the concentrator again communicates Wi-Fi or wireless Hart and Wi-Fi out. The wireless Hart is to get into the network. So we support Hart 7 is the wireless standard for the latest Hart standard for wireless communication, and we're complete compliant to that. We do meet all the standardifications. So if you have a wireless Hart network today, you can use our devices on it. It's simply put in the 32-bit code and you're onto the network. So it's very simple. So the other thing is the Wi-Fi, and I'll get into that in a little bit and show you how that is used and why that is used, but it is truly a configuration tool. So this is a plant-wide network. It differs a little bit from our Accutech. Our Accutech was meant for disparate products or measurements that are out in the field at low density, where this is for high density. Here's some key to our talk about sustainability of our device. We have 64 gigabit memory. Now, you ask, why do we put that on? Well, for one, flash memory is pretty inexpensive. We're allowed to use gigabit memory on this device. If you take a look at our device, if you take all the measurements for the life of the device and what we believe a sustainable life is 10 to 15 years. Remember, I asked you earlier, put in your mind what you believe a sustainable of your device in the field is. We believe it's 10 to 15 years. We designed the device. If you take a measurement, every measurement from this device over the life of that, it is less than 8 gigabit. So think about that. We have 64 gigabit. We talked about a little network. Those little network can support up to 8 end nodes. 8 times 8 is 64. Even a mechanical engineer can figure that out. So what we've designed and in this network is that every single device can share all the information from all the other devices. So in the future, when you have a device that goes offline, something happens to it, the ability to clone that device and bring it on. That is not a feature that's on today, but I'll show you what we plan in the future and how we activate these. It is a software selectable, software upgradable device that is backwards forward compatible. So the next thing you see here is called foreign end nodes. We know that we'll never develop or create all of the Bluetooth end nodes that are possible out there. There is human wearables that you can put on yourself and wear. There's Fitbits. We've integrated those into our device that you could have. There's all kinds of other measurement devices that what I would call are not OT or robust devices, but are more Internet of Toy devices. But there's people that would like to integrate those because a lower cost for startup. We give you that ability to integrate those third parties. And again, it's selectable. You have the choice to integrate it. You have to push it, click on it in the configuration mode and say, yes, I want to integrate that. And again, 8 devices to a CC. So why is that important? If you look at your wireless Hart network, when you look at your gateway, it's selectable how many devices you can have, but that's based on update rate. I've talked to clients that said, oh, I can put 100 devices on my one gateway. Yes, but that's only at about every 120 seconds update rate. So if you choose 1 second update rate, which is very impractical, don't ever suggest anybody do it. Our device can be programmed from 1 second to 60 seconds, but at 1 second update rate, it goes through battery life and as well as it clogs your communication. So 8 devices on one CC, that Hart gateway sees 1 device, not 8. The way we've done the 8 devices through the wireless Hart, it looks like a chain or a chain link of that drop. So as you can see them in the past and how Hart works, it's 1 device and then that packet will come all 8 measurements in 1 packet and then it's multiplying your gateway. My recommendation is probably to keep between 20 to 50 devices per gateway. And that way, and then you can maximize what you're doing with that. So next thing down is configurable. We use Wi-Fi to configure. I'll show you that if we have time at the end. I'll actually click on my device, bring it up on my Wi-Fi and show you how simple and easy it is to do. And then finally, the last 3 notes. This is zone 0. So this meets class 1, div 1, but zone 0. And our concentrator is zone 2. And battery life, we state these battery lives of 10 and 5 years. The end node, as I said, was sustainable for 10 to 15 years. I will show you data that supports that the battery life is actually longer than that. What we claim at 16-second update rate, 25 degrees C. Now, we do know that temperatures affect the battery life, but we have designed this device to minimal use of power and energy. And the concentrator, because it has 8 devices going through it, at once, this number is based on all that communicating at that time. But we believe that this life cycle of this device is fully sustainable for its whole life. So next, let's gain. Why do we have so much confidence in our battery life? Well, let's look at this chart. We use Tadorun batteries. If you look Tadorun batteries up, they're the world premier in lithium-ion batteries. Their shelf life resting battery is 40 years battery life. So I want you to keep that in mind when I walk you through this chart. Now, this eye chart is not very helpful for people like me that are colorblind, but for those that aren't, they can read this. At the very top, or as you can see on the X coordinates, this is 1 second to 60-second update rate. This is -40, which you live in Canada, to 85 degrees C. So these are the temperatures. That was a little joke. If you notice that the shortest battery life is up here at this quadrant, that is 1 second update rate, and that is at 85 degrees C. So extremely hot, extremely fast, and the battery life of that device is 1 to 2 years. That is the data we have supporting it, and that is the shortest battery life we see. So again, if you choose to have a 1 second update rate and you're operating at 85 degrees C, you expect to have somewhere around 1.5 to 2 years in your battery life. Now, at the other end of the spectrum is -30 degrees, which I was a little shocked. I thought that the battery fall off would be greater, but it really isn't. It isn't until it passes -30 degrees that you start to see a degradation in its life. But at 60-second update rate, you can see this is 25 to 26 years. So remember what I said about a Tadorong battery and its 40-year shelf life? We have designed this device that it's really taking in about the same energy as it would in resting. And that is powering the device, taking a measurement every 60 seconds and sending that measurement out via wireless HART. So what we've done is to design a device. Now, you ask me, how could we be so confident in our measurement that we can guarantee you a battery life of 10 years? Well, if you look here and you come up at the 16-second rate and you come up to, and my eyes aren't that good, but you come up here to 25 seconds and you pick the color, that turns out somewhere between, let's say, 17 to 19 years in battery life. That's our confidence. This is empirical data we have. We show and support this, and this is really the battery life of where it works. So practicality, this device can easily meet those 10 to 15 years that we believe a device can work. I still want you to start thinking about, so when you ask questions later, how long does your device last in the field? So if you look a little bit digging further in, this is a device itself, and you can see in this curve here, at 1 second, we show 6 years. And that is because it's 25 degrees C, not 85. So if you really want to operate that at 1 second update rate, you have about a 6-year life. Comparable to other products on the market today, that's probably 10 to 12 times what they can last at that update rate. Now, I don't believe it's practical. Even if you pull a PLC at the rate, you're probably going to 1.5 seconds. So probably minimum you would want to do is 2 seconds, and that's still 9 years, still close to that 10-year guarantee. And if you look up here at our 16-second, that's actually a 19-year battery life. I had a customer say that it's they only use wireless devices on temperature at 60 seconds. And I said, well, that's a 21-year device. He said his devices last 20 years. I kind of question that in the modern world, but I told him, yeah, it would last the life of that device. So it became what I wanted to say earlier, completely sustainable. No need to change your battery when you have a device that will last 10 to 15 years or maybe longer without changing it. Now, why would you design it without a changeable battery? Okay, we've talked about our confidence in what we did, our confidence in our design, how it works, okay? I'll talk to you a little bit further about why we know how it works. There's a way, if the distance gets past an infallible and it drops off, the device will start thinking about, okay, hold on, I haven't communicated, and it'll lengthen its communication path. And as you can see in this chart, if we go out to 60 seconds, you're at it for 20 years. So that's what it will do internally until that communication comes back in, joins communication, and sends it out. Okay, so that is part of the design that gives us confidence of why we can say we don't need to change the battery. So when you have a sealed devices, you eliminate the human element of opening a device and leaving it open. So that never happens, but I have seen it. The other thing is opening device and water gets in there. Now, water is not good for electronics, causes an early failure. We've seen it in Saudi Arabia, dust get into the device and cause earlier failure. So what we've done is eliminate, basically hermetically seal this device from the elements, protecting it. It has an IP67 rating, so it's completely safe to all weather environments that you would have. So you have a device that is completely safe, that none of the elements will destroy that device. And that's why we're confident in what we did. Again, sustainable. Your maintenance time is decreased. So next, this is our configuration screen. And this is what it would look like. This is a brand new release. It's not even on my device, but you would get into your Wi-Fi. You would connect to it. And on the bottom of the concentrator gives you a Wi-Fi number, but then you put this into your browser. And this is what you'd look. So you could configure a device. You can zero it, you can flash it, you can change your tag set, but it gives you that ability. No special handhelds. All you need to configure this device is an iPhone or any other thing that has a web browser. And again, this is not an app. This is actually a website that is on the device. So part of that storage that I talked about earlier is CalCert. How many people out there have bought a device, forgot to order the CalCert, needed the CalCert? Well, within the device, there is a CalCert that you can download from every device. As you can see, this one was a 0 to 300 pound device. I ranged it from 0 to 150. The red means positive error from 0. The blue means a negative error from 0. If you look at our calibration data, we claim it to be 0.25% of span. That is the total probability error. If you're familiar with the term, that's all the possible temperature and pressure errors that can, static pressure and pressure errors and temperature that can occur within the device. So when you talk about our standard device of 0.05, that is not the total probability error. That is a reference accuracy at 1 point. If you come down to the bottom of our device, you can see that if we span it from 0 to 150 and from a temperature range of -15 to 60 degrees C, that our accuracy actually is 0.039. That is 3 times as accurate as the most accurate transmitter on the market today. So we have a device that's not, and again, I said not an instrument, a toy, internet, a toy, but an industrial device. And if you want confident that this looks, you know that at the bottom end of a device is the most inaccurate. At 35 degrees C, at 7.5 PSI, we're less than 0.04 of a PSI off. So again, solid device, it's there, it's robust, it's sustainable, it gives you all the information, and on top of that, if you ever need this information, it can be drawn. So this is a typical outlook of how it works. So you would have a gateway that's communicating through via Ethernet, and that's either Modbus TCP or Ethernet IP, into your control system. Then from the mesh network, the wireless net, we say 50 meters. I know that the spec for wireless HART is 225, but I highly recommend that you shorten that to guarantee that this is an infallible distance that it works. And then from our instruments to the concentrator is 15 meters or 45 feet. And again, it can work further than that, but we want an infallible distance. So this gives you an easy look of how it works and all the benefits. A couple things I have not talked about is the connection. So really it's 2 clicks. There's simply a click here until the light comes on and another click. And as you can see it, the LED light. Why an LED light? It guarantees you what you're communicating and talking to. And then the concentrator has another LED light, another click on the concentrator, and the 2 are married. I do believe these are hooked up now, but if they're not, they will be soon. So they will communicate and blink and standard, and there they go. Now they're communicating, and that's all it took. So 2 clicks, that's it to communicate. And really, it's simple, it's easy. So finally, in closing out, this is part of a wireless HART mesh work. We can mesh with any third-party devices. So that currently is an Emerson device. If you have a current wireless HART device, it's Met, Emerson, whoever you're using today, doesn't matter. We will completely mesh with that device. There is 132-bit tag per concentrator that you have to need to add into your Met, and that is it. That is the standard communication, and you're up and running. So instead of 8 individual tags into that, you have 1 tag and your network is up and running. And finally, to close this out, what we set this as to be, these are connected devices, and this is an edge control. Why do I say that? Some of the future abilities of this edge control and this infallible network is to do math, like take pressure A from pressure B and have DP, temperature A from temperature B and have DT. You could also do output. It was designed to be a little group, sustainable group of devices with edge control that can put an output signal to shut a valve. So you can imagine the tank, a very slow moving measurement. And then output of that is to a valve. Now you have an autonomous group. That's what a wireless network is, an autonomous group that can perform little functions such as that. And finally, what could you do? And I call this the what ifs. I told you about all the other measurements that are on board this device. On every single board, there's 2 accelerometers. Those are 3-axis accelerometers. There's ambient temperature, there's pressure, there's humidity, there's an impact switch, and there's an acoustic. We actually have a microphone on bus, all attached to a real long-time clock. And then there's 2 inside all that memory we have, 2 historians, if you would. One is a measurement historian, one is an audit trail. Both of those have designed to last the life of the device. So they are right now off, but we can turn them on with a software selectable. Again, download software, upgrade the device to where it's at, and turn all these devices on. So you're going to ask me, what does it matter? What vibration? Could you imagine your device sitting on your pumps, on your treads, understanding all the vibration that happens? Or the acoustic, understanding when cavitation happens, in the upstream world when there's gas flow by. And then impact. What about water hammering your process? All those things are available and they're sitting there. So what we like to say and call this is process analytics with actionable intelligence. And why do I call it actionable intelligence? The difference between data and information, data is ones and zeros. Information is usable data that we can use to do it. Our plan was never to make this an accelerometer that you get a G-force off, because what does that G-force mean? The plan was always to baseline your operations at zero. And then as a trend comes up, you would get an alarm. And today in the Hart world, that's what would happen. A Hart status would come off and say, we're outside of our vibration range. You need to look at the device. You would go to the device, download through the Wi-Fi and pull a trend that's out of the device and say, okay, now we're there. I use the same analogy to cars. We've talked a little bit before about cars. Well, you know, Tesla has a download soft gradable feature. You can upgrade the car to the next rev level. We have the same. Here comes the other, is the vibration or these analyses that we have on board. If you look at your car will tell you how much oil life is left. It'll give you a number like 38%. I just looked at a car the other day and I said, what does that mean? I have no idea what that number means in the real world. So what do we get? We get a thing that says service engine soon. But if you really deal into that service engine soon, it'll say change your oil. And if you dig into the oil a little bit further, it'll say, oh, I got 5% left. Okay, I know that I have a week before I have to take my car in. That's exactly how we designed it. So again, process analytic with actionable intelligence. And we're not going to just provide you with asset level management, which means device level. What we're going to do is real process and real asset, your rotating equipment. The design in the future would be to maybe use another radio besides wireless Hart. And again, we could change this out at any time and put Bluetooth to Bluetooth, 800 bits or packets a second versus 40. Now it gives us the ability to tie these analytics into apps that could do more. The sensors that are on the bottom into your analytics on the top. Now that you can look at your pumps, your rotating equipment, understand that every 18 months you need to pull these down because of the vibration. Now you have to change your bearings or whatever that may be. Those are examples of what the world looks like. I told you at the start that digitized information, and really what we're providing is digital transformation of your process automation, or today's term OT. With that, I open it up. I got it done within, I'm 2 minutes underneath my time. I know I speak fast, but now I'll open it up to questions if you have any. Paul?
Thanks, Quinton. I don't see any open questions at the moment in our panel, but let's fire one off you there. So how would you say that the pricing of this of our devices in this wireless Hart network compares perhaps to other systems that are available out there?
Okay, so if you look at how we compare to other wireless Hart devices, we're about 30% of the price of another wireless Hart device, and that includes concentrator and end node. So are you able to tell us if these devices are CES, that is Canadian Standards Association approved? Do we have that certification? So these devices, the IS, and that was that IS Canadian. So they are certified with an international standard that does meet the CSA requirements for these in zone 0 and zone 2. So yes, the answer is yes. What's been your impression of how long it takes to sort of implement these devices in the field? It looks like they're fairly quick to just hit the button. Yeah, so, you know, I say this, and I'm going to show you the picture again. Literally, so these are joined now. If I want to disjoin this, and I ask you guys to invite me out, then I'll show you how it works, but I want to disjoin it. I'm going to push and hold it. It takes about a second. You can't accidentally do it. Push it again, and now it's disjoined. I want to show you, this is literally how fast it's going to take. Okay, they're disconnected. All right, on the concentrator, we want to turn the radio on to start listening. Watch this, and you can time it. Okay, I'm going to hold it for about a second until the light flashes. All right. Now, the other devices within the network are already flashing, so they're all communicating. I know this one's not connected. I want to push and hold this for a second, and now the light starts to flash. When they flash in unison, they're connected. All right, you tell me how long that took. Now they're coming. There you go. Rapid flash, it turned it off, went back to sleep. So tell me how long that took. That's it. What, a couple of seconds? 2 clicks, and that's it. The only other thing is to get that into your network, you have to add the 32-bit key. Okay. All right, so I hear this is a question. Should the CC be mounted high in the ceiling to avoid interference? So what I'm going to say to you is there's a standard about how far you get it off the floor. You need to put this is a line of sight. Wireless Hart is line of sight, so put it up high, make sure it's away from interference so that it can see your antenna or the next part of a mesh network. So yes. What's the typical range for BLE? We say 15 meters. If you go look at the standard actually that's available out there, it is further than that. I would challenge you to go to a website. It's called BLE, and the BLE website gives you a standard, and you could look at, we say 10 to 15 meters. We can go 20, but that's inside a steel building, like an office environment with lots of other signal, lots of metal. If you're actually out in a process plant, with the way we've designed our antenna, they can claim 100 meters. But I say keep it shorter, keep it inside those distances. So we're saying 10 to 15. If you go to the website that they have, the BLE SIG group, you can punch in the information that we have on our device. It's +5 in power at the receiver, +5 in power on the transmission, and they'll give you, if you turn the power up enough in the right antenna, if we use this antenna instead of the ceramic, they say a kilometer. I would never put it at a kilometer, but there again, I hope that answers your question. Mount it so it's in good visible. That was the other reason we separated these two. I guess let me hit that one. Normally what would happen, you have an antenna coming out of this. If you couldn't get it up into the measurement, we've done it with Accutech, you would take a coax cable, put it up in the air. Problem with coax, they corrode. They're not always working. As somebody told me, coax works until it doesn't. This is your antenna, and we maximize location of that. Any other questions?
I don't see any other questions there. Are there any other offerings out that have as many active antennas in the system as we do?
No, not as many radios. So we have 3 radios built into this, and it is meant to be modular. As I said today, what we offer is wired wireless Hart, Wi-Fi, and Bluetooth. We will always have Bluetooth and Wi-Fi. The top radio could change. We believe there's a world that will show this as an LTE. So basically you would now have a device, and you might ask yourself, there's people out there today that offer LTE devices for one measurement. What concentrating your measurement into one cell signal will reduce your cost? One of the vendors on the market today says $168 per measurement available. Well, the way we work, it would be 8 times, divide that by 8, and that would be the cost per year per measurement. So just think about that. Any other questions?
I don't see any other questions in the list here, so it sounds like you've managed to cover all the bases, Quinton.
Okay. Well, let me show you something real quick. And somebody asked about I will put this in the presentation. So this is the screenshot that I wanted to show everyone here. You asked me what's the distance, what it could be on this. This is actually out of the Bluetooth SIG site, and you can select, we're about 500K for communication. Since we're not streaming, that's perfect. Our 5 and 5, and it shows plus, in industrial world, it shows plus 140 meters. That's what's possible. I would never recommend it. That actually has to do with the design of the antenna. So when we go next generation Bluetooth, where from each hop would be over 140. But if you play with this and go to the website, again, it's Bluetooth. If you Google it, it's user group, go to the range estimator, and you can find it yourself, and you can play with it. In an office, it's a lot less. The reason it's a lot less, there's metal walls, there's metal everywhere around. So just remember, you want your measurements to work, not stretch them until they don't. Anybody that's familiar with our Accutech product, there was times that it was used, and customers said, hey, it quit communicating. Well, we had it out at over 1 kilometer, and what had happened? Truck had pulled between the wellhead and where we had the base radio or the gateway, and that had blocked the communication. In doing so, it can try to communicate and continue to communicate and wore the battery out. So again, that's why we've done the things we've done to make sure the lessons we learned on our first generation of product, we've changed in our second generation. Any other questions?
I don't see anything else here, Quinton. So if anyone else has any further questions, hit that Q&A button there and type it in.
I do appreciate your time today, and I hope I've been informational to you. Jerry, Richard, thanks for the questions. If you have any more, please send them to me. You can get them to Paul, and he'll get them to me. And if you like, I would love to come and visit you. Just make it before the snow blows. But knowing my life, I'm supposed to be in Bismarck, North Dakota, the last week of the year. Good luck. Thank you, Jesse. Appreciate that. I'll be in the last week of January, which I know is historically the coldest week in Bismarck, North Dakota. So I'm not afraid of the cold.
We'll be able to test the battery life there.
Exactly. So I've been there at 50 below with a wind chill, and it was not fun. So thank you so much. And again, everyone have a great, summer is over, what's left of it. Enjoy yourself. Again, appreciate your time today. Thank you so much.
And with that, we'll wrap it up. Thanks for everyone participating. I hope you have a good what's left of summer.